Hello everyone. Welcome to the VisGuides workshop. It's my pleasure to have you all here. My name is Benjamin Bach from the University of Edinburgh, and I'm co-organizing this workshop together with my colleagues Alfie Abdulrahman from King's College London and Alexandra Deal from University of Zurich. This is the fourth workshop on the creation, curation, critique, and conditioning of principles and guidelines in visualization. And we had 3 workshops in the past. Our history stretches back until 2016 with the first workshop on this topic, not organized by us, but by others. And in the past, we had some really nice panels by these contributors. We had paper presentations as well and some discussions, and it's really nice to see this community growing, so thanks everyone for contributing to these past workshops. Today we have our fourth version of this workshop again, and we want to think about the collection of guidelines, about principles, recommendations, maybe even laws that we have in data visualization. Can we come up with laws? You tell me. We want to think about the application of guidelines in different contexts. For example, in the wild, where we're working with collaborators, with people who are not trained as data visualization persons, and we have to represent our field, we have to represent our knowledge. How do we do this? How do we explain that? How do we engage people with the knowledge that we are? How do we present that we're doing the science? We want to talk about, or think about education with guidelines, for example. It's one area that always comes into mind when we think about guidelines, is about knowledge, transmission, and so on. Can we think also about guidelines for guidelines in order to think about best practices, how to use guidelines? Because obviously guidelines have their pros and their cons and principles at all. So how do we go about this? How are we critical about guidelines? How do we create them? How do we, work with guidelines? And what is the difference about theory and practice if we think about guidelines, principles, visualization, knowledge in general? Because the theory might be one thing, the practice is another, as I'm sure many of you know. Can we also think about the formalization of knowledge through guidelines, principles, and so on and so on? Because once we have such a formalization, or once we have a guideline or a hypothesis in the world, then we can scrutinize it, we can reflect on it, we can discuss it, we can prove it or disprove it, and so on and so on. And eventually we also want to include the implications here. What are the implications of the research we're doing, the guidelines, the knowledge we're creating? How are we ethical about these things? How are we make practical? How is technical manageable to do all these things that we do? And we put out a call for papers for this workshop, which asked for comparative analyses for guidelines, which asked for the critique of guidelines, which asked for case studies, for new principles and guidelines. Of course, we do many of these things in our research. We're looking for major revisions of guidelines. We're looking for mechanisms for curating them, for frameworks, for a critique, a structured critique to guidelines and visualization knowledge, towards means of disseminating these guidelines, mechanisms for prioritizations, visualization activities, how to engage people with guidelines in co-design or education or whatever, about relationships between these guidelines or even taxonomies, and so on and so on. You can see on this slide that this could go on for ages, but that was just some points we wanted to put out in the world and ask for contributions. And we want to thank very much the organizers and co-organizers and the program committee of this workshop to set us up, to help us reviewing papers. What we ended up with are 7 papers by 36 authors, so congratulations to all these authors of having the paper submitted. We have some of them here in person today, and others are going to be presenting live. Now, the schedule for today is we have a keynote, which I'm going to introduce in a second. Then we have a first session of paper presentations, which is going to be virtual. After 3 paper presentations, we have Q&As. And then we have, again, paper presentations by in-person authors, and again, a Q&A. So keep in mind, put all your questions into Slido, and we then going to pick up these questions after the paper presentations. So we just want to smoothly run through these presentations first and then have a wider discussion. And then it's time for coffee. And after the coffee, we come back to do some more hands-on stuff. So we really want to work a little bit on this topic and not just listening to talks. But we thought we're going to can do some breakout groups. And looking at the audience right now, it looks like there is really some people here who want to discuss. We have 3 main questions or big topics that we were interested in discussing, and we introduce more of them later on. So we really want to get you guys together, discuss, think about some actionable outcomes of how you could go about what is your next research about guidelines. And if you're not yet on Slido, you can find us in the virtual program. If you navigate to the Monday afternoon program, we are here on the bottom, VisGuides. You can click there, you can find Slido, and put your questions in Slido. And one more thing on questions. If you ask a question in Slido, please put the name of the author you're asking this for, so that we then can kind of balance the question that all the authors get a decent amount of questions. Without further ado, it's my pleasure to introduce our keynote speaker, Sheila Carpendale, who's going to talk about best practices considered harmful some of the time. It's really a pleasure to have Sheila here. She's a professor at Simon Fraser University now, moving from Calgary. She has also been a co-organizer of the Dachstuhl seminar on visualization empowerment, how to teach and learn data visualization. And she's an outspoken critique of guidelines, and that's exactly what we're going to do here. We don't want to advocate only for one direction of guidelines, but for the holistic view, and that's why we ask her to give the keynote. So thank you again, Sheila, for accepting this keynote, and looking very much forward to your talk now.
There we go. Hello, everybody. Thanks very much for inviting me to do this talk. And yes, as Ben told you, I put the title, Best Practices Considered Harmful some of the time. I am going to start this talk like I usually do by acknowledging my current group of students, usually because I say that, as we know, our students do all the work. But here I'm kind of a little bit wondering if they may be slightly embarrassed in being associated with this, because I'm going to say some things that are not universally agreed upon. So let's go a little bit of an outline. I'm going to talk about with, some sort of simple definitions of guidelines, heuristics, and best practices. And I know I just titled this, but I could have actually said, heuristics, guidelines, best practices considered harmful. I picked on best practices because it has an extra factor that causes harm. But yes, so, and then at end, look about going forward to possible mitigations of how to use these things with perhaps a little bit less harm. And I want to acknowledge
Sheila, may I briefly interrupt you? We don't see your slides. I think you need to share your screen.
You don't see my slides. Oh, no, my goodness.
I apologize. Okay. I was just taking the tech. It's a tech.
Okay. Let's just see if that works. Do you see my slides now?
We see your slides now. Yes, perfect. Thank you so much.
Okay, sorry. Thanks for telling me. To acknowledge the use of the title from Saul and Bill, well-known paper, Usability Evaluation Considered Harmful Some of the Time. So given that, let's actually jump straight into heuristics. So this is a definition from Wikipedia. A heuristic or heuristic technique is any approach to problem solving or self-discovery that employs a practical method that is not guaranteed to be optimal, perfect, or rational, but nevertheless is sufficient for reaching an immediate short-term goal or approximation. So they kind of like build into the definition that it's not always perfect, but that it will help. So there's a method, you have a list of factors to consider, or the heuristics. You usually have a set of evaluators because different ones will use the heuristics in different ways and come up with different problems to fix. The procedure, and the important point here is this is something that is, the advice is to do it after you have created something. So it's post hoc, right? And for each item in the heuristic list, the evaluator inspects the interface, visualization, etc., and picks out factors that need adjusting, considering, and redesigning. And so Jacob Nielsen wrote a lot about this. He actually made a little bit of visualization of, looking at usability problems and evaluators for using heuristic evaluation, showing that not everybody gets all of the problems, and that's why he was recommending 3 to 5 evaluators. And that some usability problems are harder to spot than others. And this is just a sample of Nielsen's 10 heuristic principles, and many other people have drawn all kinds. And we're not going to, in the 10 minutes of this talk, we're not going to read all of these because it would take too long, but there is a reference if you feel like looking them up. Mostly for interfaces, they're still relevant. Okay, so this is an example using drawing, right? So the heuristic could be that outlines should be, respected. And so if you are the heuristic evaluator, you can look and you can circle or point out all the points where this heuristic isn't followed, right? Fairly simple to do, okay? Now let's look at guidelines. So I took a bunch of definitions here from Oxford, from Cambridge, and from Merriam-Webster. A set of rules or instructions that are given by an official organization telling you how to do something, information that suggests how something should be done, a line by which one is guided to aid somebody passing over a difficult point. So the method is actually applied during the design. So with a chosen set of guidelines, use and check as one proceeds. So in some ways, when you look at a set of guidelines, they may actually seem fairly similar to a set of heuristics, and you could actually use them as heuristic and apply them post hoc. These are, well-known people. We all know Ben Schneiderman and Don Norman, and so these are sample guidelines that at different points in their career they have published. One of the things about guidelines is actually anybody that you admire their work, you can look, you can do the analysis and pull their guidelines out of what they have written and have guidelines according to somebody else who may not have actually assembled them themselves. So a guideline, so again, using this drawing examples, so the guideline will say stay inside the line, so it's more kind of like active, and it tells you that the outline can help you create your results, and it might help you get a slightly more compliant. But when you're drawing with a mouse, you're probably not going to get something very compliant anyway, right? At least not if you're me. I don't draw with mice very well, though I certainly have students who do. Okay, so that's heuristics and guidelines, and now, very briefly, best practices. So best practices are related to how to carry out a task or configure something. A best practice usually presents the optimal way to work. An organic best practice is usually formed naturally over the years of trial and error that make it clear that following a certain procedure is better than any other procedure. An established best practice is created by an organization or a society or a manufacturer through research to set guidelines or benchmarks for other organizations or people within the organizations to follow. So this is from TechTarget, which is a website telling us how to work in technology fields. So this is, again, an approximate method. It's intended to become part of a learned process. It can have lots of details, even physical details, like how to hold your hand and stuff about your posture and stuff about taking breaks and all kinds of things. Best practices incorporate all kinds of how to process. And again, this is during. And the idea is that you practice and learn them for more optimal results. And you use them to criticize and examine the process as well as the results, which is, again, sort of the bigger, it's more that guidelines are more like helping you how to get to the end. Best practices often involve like looking at the how. And so, for example, if we use our drawing example, a best practice might be start by following the inner curve in order to establish a safety thickness before speeding up to fill the center, which is a process, right? By which you, including even me with my terrible mouse drawing, could stay within the lines, right? Okay, so let's look at the benefits, right? So Nielsen, he was mostly talking that it was really important part, heuristics were really an important part of discount usability. And that's that, like, to get rid of the really rough edges of a piece of software quickly without much effort, very fast results with a lot of improvement. Mind you, maybe not all improvement. So yes, definitely they can eliminate significant usability problems. They can play an important part of getting the design right. In other words, once you have a design, polishing it off. This is kind of like, the sandpaper effect. Take off all those rough edges, right? And you can develop heuristics, like I mentioned earlier, according to researchers, designers, inventors you admire, so you can have all kinds of different heuristics, guidelines, best practices, right? How does somebody I really admire do this? Let's learn how to do their process. Okay, so where's the harm, right? All of that sounds great, right? So where's the harm? So, one, all three of these things put a clamp on creativity and thus may eliminate the best. So here, if you kind of have a hypothetical graph of all Viz solutions, continuing to get more and more of them over time, and the y-axis goes from bloopers to fabulous, you can pretty much guarantee that good use of all three of these things, heuristics, guidelines, and best practices, will eliminate the bloopers. And I think that's part of the reasons why we have been so keen on them, is because we want to, have less really awful ones, damaging ones, dangerous ones, ones that lie, etc., right? But in doing that, they also eliminate the best. Okay, so that's one harm, right? And another one is this. I mentioned that these can promote getting a given design right, but they do not promote getting the right design. And if you've read Buxton, you know this well. So this is the idea about getting a design right. So these kinds of guidelines, best practices, etc., can help you once you've given an idea to get, think about it more deeply and adjust until you actually, get the best version of that idea possible. Okay? But the problem with that is that, is it the best idea? And really, you may have been local hill climbing. There might be all kinds of other ideas, many of which would be better than the one that you have been carefully working on. So these things do hone one in to where one is already. Okay. So promote getting the design right rather than getting the right design, helps us polish off a given design that is not fundamentally the most appropriate design. Okay, so another harm, and I talked a little bit about this earlier, is they assume generalizability. And I think this has been a pitfall of technology since the early 80s. I don't know why. I have no idea why our technology industry has assumed that everything should be generalized and that we should all use the same interfaces, the same interactions, the same visualization. We aren't all the same. And we are now with, thought about diversity and EDI, starting to recognize that, we're eliminating wide classes of people like people who have different types of challenges like in vision or hearing, etc. But even people from different cultures and different ways of thinking and different ways of assembling knowledge. All of these assume generalizability. But and why I kind of put the title for best practices is there are all kinds of problems with generalizability that go beyond this notion of eliminating the best and not getting the right design. Is because, like, if I do a whole bunch of like really careful work and come up with all of the best practices and tell you guys all about it, I'm assuming that you're all like me. That's what generalizability. It doesn't actually exist. Generalizing promotes ableism, elitism, all of those kinds of things. So, we should think about how much we are creating Viz for weird people. And I think you probably know that acronym, white, educated, industrial, rich, democratic people. There is a paper, How Weird is Kai? We should probably have a look. How weird is Viz? I bet you it's just about as weird as Kai. These are all kinds of references who talk about the problems of assuming that what is best for me will be best for somebody else. And part of the problem is the use of the word best. Like, that is actually from, decolonizing methodologies. It's very colonial if I assume that my way of doing it is best for you also, because I don't know your way of thinking. So, yeah, a bunch of references. So harms, right? Puts a clamp on creativity, promotes getting the design right rather than getting the right design, assumes generalizability, and ignores the concept of power in Viz. And I just heard somebody else talking about power in Viz when they were talking about an effective line graph or scatter plot, but and it being done well so that it was powerful. But what do I mean about a powerful representation? I think it goes much beyond that. I think we all as a community ignore power in representation because powerful representations are usually non-intuitive, usually take a long time to learn, in the order of years. In fact, because of this, I've heard people argue that these aren't visualizations, but the rewards for putting the effort into learning is huge. So these notions of the fabulous and the best things may often take a long time to develop, be very hard to learn, but give one a lot of power. So just quickly, a couple of powerful representations are written language. It takes a long time to fully understand, to read, to write, to become literate, 2+ years, but it's powerful. We insist, whether they like it or not, that all of our children become verbally literate. Another one is mathematical notation. Definitely takes a long time to learn. Also hugely powerful. Ditto with music. We aren't so keen on making everybody learn math and music, but the first one we insist that everybody makes. So harms. Promotes getting the design right, interferes with getting the right design, interferes with invention and innovation, assumes generalizability, which is anti-inclusion, and ignores the potential for power. So possible mitigations. For all heuristics and guidelines and best practice in old design school advice, this actually, in fact, given this, you could still make use of all of the stuff that's out there. So this simple bit of advice says that it is foolish not to learn all existing heuristics, guidelines, best practices. However, it is even more foolish to apply them. It is really important to learn them because there's huge insight into how somebody else or some other group of people have learned to think about the problem that you are now tackling. And that's really empowering. However, you shouldn't assume that you should just apply them. And even more, you should not look at somebody else's work and say, person Y is not doing it as person Z did it. So I don't like person Y, or the way that they've done this. So don't apply somebody else's best practice to a different person, a different group, a different way of thinking. Okay, so possible mitigations that can help mitigate these biases that so often occur in generalizations. And you probably have seen that some papers carefully call what they come up with as a result as lessons learned rather than best practices. And actually, I can probably be super embarrassed and look over all my papers and find that I've used them willy-nilly, one time one, one time the next. But actually, if you think about it, lessons learned acknowledge that I have learned something from doing this research, and I will tell you about my learning. It's always first person. It will be either we as the group or I if it's single. And these can be phrased as any of these things, but they're acknowledged as personally preferred methods. And so then you can actually make use of lessons learned from all kinds of different people and develop your own process that is enriched by what you've learned from other people. And I think this is a really important distinction because it's not implied to be generalizable. You can use it in consideration of other current variations, and it is usually applied self-reflectively. And I think it's a subtle difference, but an important difference. So it's possible, learn, but do not follow heuristics, guidelines, and best practice. Do not assume generalizability. Do not apply your favorite heuristics, guidelines, best practices to someone else's work, like in reviewing. Make use of lessons learned when you are writing about what you would like to pass on, and beware of respecting individual differences. Embrace design thinking for help in the notion of getting the right design. So I think maybe I've gone a little bit over, but thank you for listening. I don't know if there's time for some questioning. I'm not sure how we move to questions here.
Thank you so much, Sheila. Thank you so much. We have time for a couple of questions. Please put them in Slido. Yeah. And while you do so, I have a very first question. Thank you, Sheila, so much for these paradoxons on your last slide, which is basically guidelines of how to avoid guidelines.
Yes, this one, right? Possible mitigations, these ones. Right?
I'm really, really curious. One thing you said was that you can go into many people's research and find out the guidelines that they personally found valuable to them. How did you use the guidelines in your own practice? Do you have a notebook and you write down things or lessons learned in that case for yourself? Do you have a personal practice of dealing with these things?
Well, for example, when I was still a PhD student and I'm looking at all of Tufte's books, and I thought, well, let's go through them and assemble. So, as a designer, one of the things that one does is, respect people who are great designers. And Tufte books are full of fantastic examples, et cetera, right? So I took it on as an exercise to pick out his guidelines, of which he has many, very emphatically spoken. And lots of them are contradictory. In the design world, I think that's actually even quite common. But you can pick out, I did the same with Colin Ware's text. Not so contradictory. Much more logical. But you can do it as a process of research. You can look at somebody's work that you admire and glean what their principles are, but then you can think of them, and you can even think, do I actually want to apply, Tufte's principle to this visual design that I'm making? Or maybe I want to think about this from a more cog-sci perspective and apply some of Colin Ware's principles. You can pick and choose and think about ones that might work better in a given situation.
Thank you. We have time for one short question. Petra Eisenberg is asking, how much visualization confidence does it require to go against guidelines?
Well, I guess that depends on how much I guess that's a very personal question. And actually, it's confidence or risk. I mean, to me, it's not so much a problem of confidence, but I know that when I am going against established guidelines, which I often do, as many of you know, the risk is, can I get it published? Will the community listen to it? Can I talk to people? I mean, I do think that some of the very best work that I've done, I have never published because it doesn't fit under normal guidelines. And so reviewers say, but you didn't follow what I think are best practices. So it's a risk. And yeah, you have to think about whether you're willing to take the risk at the time or whether you feel like you need to play it safe for career reasons. I think it's, a very personal balance.
Thank you so much. We have time for maybe one. Do we have still time for questions, tech chairs? No. Okay, we have to move on. Sheila, thank you so much for your talk. In Slido, if you want to catch up with the questions, you can go to Slido through the virtual registration. I'm sure we can send you the link to the Slido slides, and then you can, I think, reply to these questions in Slido. So again, thank you very much.
If you could send me the link, I would much appreciate that. That would be great.
We will. Thank you so much.
Hi everyone, my name is Lena Cybulski, and with this work we would like to encourage discussions about knowledge elicitation as a means to inform visualization design. We often say that an effective visualization design must take domain knowledge into account. To extract this knowledge, we typically engage in a domain characterization, where we study how domain experts work and what their needs, tasks, and goals are. Personally, I often struggle with doing so systematically. I think this is mainly because how domain knowledge works is really hard to untangle. When we look at visualization design theory, it does not really tell us how exactly to do domain characterization. Also, practical design studies, they do not detail the steps they follow. And even if they provide richer reports, it often remains unclear if they reflect the individual choices of a researcher or if they follow a methodological protocol. So we looked into cognitive science, where they research knowledge elicitation techniques. And we proposed to use an interview technique called the critical decision method. It consists of 5 steps that walk through an incident multiple times. You can find 3 different incidents in the paper. For now, just imagine an engineer who has been given the task to design an efficient water turbine. First, we listened to the engineer describing the design of the turbine from beginning to end. We focused on understanding the story and did not interrupt him. This is a stage we do not typically encounter in interview approaches. We then reconstructed the described turbine design process in the form of a timeline. We also identified decision points. Some of them were obvious from verbalization. For example, the engineer said, "Now we want to start the simulation." Others included subjective assessments. For example, "I see that the flow is good." The timeline is then retold to the engineer to identify inconsistencies. Finally, we asked the engineer about the decision points in more detail. We asked questions like, based on what constraints did you exclude these options? Where do you see that in the visualization? And how do you know what parameter to adjust next? So from these interviews, how do we move towards something that can inform our visualization design? We derived a situation assessment record that represents the evolution of the incident together with goals, options, cues, and so on in a very structured way. It is complemented by a table which specifies for each decision point what particular decision was made, why it was difficult to make, how it was made, and what supporting information was used. We think that the critical decision method is quite promising because it provides a structured way of eliciting different perspectives on domain knowledge. It reveals different types of knowledge, and it also highlights cues that steer the expert's attention, for example, too much curvature in the pressure lines. The situation assessment record in particular specifies how the expert's mental model of the situation changes dynamically. Although all of this does not mean we have found a way to formalize tacit knowledge, we suppose the results significantly help design problem-driven visualizations. With our work, we hope to have motivated the relevance of knowledge elicitation to the visualization field. To initiate discussions, we would like to highlight some open issues. So one question is, how can we link the proposed method more tightly to visualization design, for example, by developing new probe questions? And we also need to confirm that the critical decision method actually helps improve visualization design. This might involve replicating existing domain characterizations, which would basically mean to compare methodologies rather than visualization techniques. And then finally, the question is how to move from there towards guidelines on how to design visualizations that foster the exploitation of domain knowledge. Our work also raised some general questions regarding how to do design study in the wild. So should we, for example, complement task analysis with domain knowledge analysis? Do we need more prescriptive domain characterization models? And if yes, what should they offer? And also, how does such a model relate to visualization guidelines? With this, I would like to thank you very much for your interest and kindly invite you for discussion, either with me virtually or, for those of you attending in person, with my fellow researcher Jörn Kohlhammer, who should be somewhere among you. Hi everyone, my name
If you put a question in Slido, please put Lena at the beginning of the question so we know who the question is for. Thank you.
Thank you, Ben. All right. So we have time for questions. Jörn is here as well, so please feel free. Thank you very much, Lena. Yes. So we continue with the next presentation now from Elena Molina López from the Universitat Politécnica de Catalunya. She would be presenting how should we design violin plots.
Design violin plots. First of all, what is a violin plot? It's a type of chart that shows a representation of the distribution of data. It is suitable when the representation of individual samples is less important than the overall data. They were created as an extension of the box plot by Hinz and Nelson, who add the density trace as a line and mirror it around the vertical axis. In the literature, we can find several combinations, from the simple one that does not add the box plot to others that add other auxiliary elements, such as VisGuides. We were interested in how these auxiliary elements affected the estimation of the values represented. Therefore, we created a user study that was deployed through Prolific and to friends and colleagues. We prepared our set of designs based on what we found in 2 years' papers from Eurovis and Vis conferences, and also from the first 100 results from a query to Google Images when looking for violin plots. Finally, our designs had 2 violin plots, and the 3 variables that were studied were the auxiliary element, if it was a simple design, with a box plot or with a VisWorm, the mode, if both violin plots show a unimodal distribution, or if one of them had a bimodal distribution, the relative position was decreasing, equal, or increasing. The Kaggle dataset that we used had NBA players' data, and we used the variables of height and position. Each user had to perform 4 tasks with 16 plots, and in order to filter those users that did not understand the task or were not paying attention, we add some introductory and control tasks. The filter did not work, so we had to control it manually. Finally, we accepted 39 users. These were the 4 tasks. 2 with a binary response. The first one, choose the player position in which there is a larger density of players. The second one, guessing which player position is more likely to belong to a player with a given height. And then 2 with a continuous response. Guess the percentage of players above a given height on the left plot, and determine the average height of players on the left plot. We are talking about the left plot because it's the one that is nearest to the axis. Since the results for the tasks did not show statistical normality for the analysis for the binary ones, we applied a generalized linear model of binary response and performed a descriptive analysis on the distribution of the errors, then use a complete model without interactions, and finally, a stepwise model and its validation. For the continuous ones, we applied a normal linear model and performed a descriptive analysis as before, then use an additive model without interactions, and finally, a stepwise model and also its validation. For further details, please check the paper. With the results, we ended up having more questions than answers. Regarding the hypothesis that we had, we rejected that it was easier to estimate the average with the box plot. We accepted that it was easier to compare weights having unimodal bimodal combinations. We rejected that it was easier to compare densities at a given y position when the plots were at different heights. We rejected that it was easier to estimate percentages with bimodal distribution, but indeed it was for point estimators as the average. We didn't have enough information to decide if having a box plot or a bisworm helped the accuracy of estimating percentages. And we found that the interaction between mode and relative position was not significant, but when estimating the maximum density, the error depended on the auxiliary element. Finally, our first advice would be to avoid bimodal distributions and to keep the design simple. But much work remains to be done with violin plots. And finally, thank you for your time. Hi.
Thank you very much. Well, now we will continue with the talk of Artsu Költekin from the University of Applied Science and Arts, Northwestern Switzerland. Welcome, Artsu. Artsu, we cannot see your presentation yet. We cannot hear you either. It will take just a few seconds. Okay. So, we have a few more minutes to think about questions for the presenters. Lena and Elena.
Which one was which?
Yeah, maybe we can take this time, kill this time by asking one or two questions. I don't know if that would be a reasonable strategy to follow.
Hi, Alex. Am I back?
Yes. Now we can hear you, Artsu. Welcome.
Sorry, can I try again?
Yes, please.
All right. So I'm going to just try to share this once more and see if I can rush through without breaking it. Apologies for the technical problem. Zoom quitted unexpectedly. Hope it doesn't do it again. So I'm very happy to be here. I'm Arzu Çöltekin. I'm presenting a short paper with Alisa Goodman. And that is about a small project, reach out project we called 10 questions about visualization. I know that there's groups of people who don't like the Z in the Viz. I also actually would prefer an S, but we ended up doing that at some point, and now it's all in our logo. All right, so I started, I do a lot of human factors experiments with visualization. I come from geospatial, a lot of maps and that kind of visualizations. And at some point I was asking myself, like, what is a good visualization? And of course, the answer is it depends. What does it depend? Maybe these 3 dimensions is what it might depend. You have human factors, you have technology and design factors, you have contextual, task-related factors, so it depends on the purpose, obviously. So human factors such as perceptual things and cognitive things, I'm not going to read through these because it's a 5-minute talk, but there's a lot of little things and each of them interact with each other, right? So it's the same with the technology and design. You have display types, you have elements of design, line thickness and visual variables and color, you have human-computer interaction, you have computational performance issues, and all that, it collects into a huge variable, and you can take, and it's the same for the contextual, one can perhaps think about low-level and high-level ones. Low-level being, in every visualization, one has to do a visual search and a comparison and things like that. And high-level could be perhaps if you're designing for an ambulance driver, every second counts, but if you're designing for someone who has 2 years to figure something out, maybe it is something else. So all of these things interact with each other. So you could say, all right, if I'm doing a wayfinding thing, do I do it in 2D or 3D? If I do it wayfinding in 3D, does it work for someone with that kind of visual ability or spatial ability or visual spatial memory capacity, say age and expertise and things like that? I know that these are binary boxes and it disturbs some people. I meant them as continuous, everything interacts with everything. It helps me when I'm designing experiments to understand factorial designs. But this gives me then the clear answer that, okay, most visualization answers end up with it depends. What if instead of giving people pre-digested answers or instructions, we would ask them questions? And this is what Alisa and I came up with. We thought that maybe it's interesting to rather tell them, ask yourself, who are you designing for? And, what is your purpose? And so on and so forth. We think that there's merit in this approach, and this 10 questions may not be final. It's kind of a work in progress, but we came up with some of these questions which we thought mattered in our work. I come actually also from geosciences. She comes from astronomy and space sciences. And when we do visualizations or when we work with people who do visualization around us, these questions seem to pop up as important questions. They may not be final, as I said. I'm very happy to hear some input, but we collected them under some sort of an interactive blog and hoping to reach out for people who are not in the Viz community. So far, I think we are still talking to others in the Viz community. But so literature review is ongoing. So we are trying to justify each of these questions with evidence from literature. And talking about reaching beyond this community and asking them these questions, I wanted to give you one example in my very limited time. And just recently we published something. This just proof is going out now with a colleague in Poland, Izabela Izabela. So we have the rainbow colors, and we looked at how often they appear, and in the visualization outlets the numbers are dropping. So we know that it's not good, especially if the data, quantitative data that contains order, and visualization community is learning that it's like less and less. But if you go outside visualization community, you have remote sensing, you have hydrology, you have geography, you have neuroimaging, and these are like randomly selected disciplines. The rainbow colors persist. So the idea of trying to go outside our community remains as a question for us. And we thought that these questions that we have prepared might actually help. And in fact, it a little bit corresponds to what Sheila said about like not giving straight guidelines and imposing guidelines. Instead of saying, this is the right way, maybe we can stimulate people or invite people to think. So I'm going to finish here. Thank you very much. If you have questions and examples, please join us. We are at the10qubits.org, and we are on this Twitter account. And thank you very much for your attention. And sorry about the technical stuff.
Okay, so before we pass to so we have almost zero time for the second part. But if someone have an immediate question, we will take it. Otherwise, we have a lot of time in the discussions after the presentations, and please write down the questions in the Slido, and we will pick those questions at that time. Also for Sheila. Okay, thank you.
So next we have the in-person presentation. So our first in-person presentation is by Yannick Metz from ETH AI Zurich. So Yannick? We seem to have collecting laptops around here, so yeah.
Okay. All right, not quite right, University of Consens in my case, but very excited to be here and to present our paper on semantic color mapping, a pipeline for assigning meaningful colors to text. In visual text applications, we often use color scales to encode information like categories, tags, or relations. However, color assignment is often chosen arbitrarily and not regarded as a prominent design consideration. We argue that applying meaningful colors to text can enhance comprehension and comparability. For some applications, we can utilize color assignment, for example, based on cultural references or even image queries. However, for many applications, this is not possible. And so the question arises how to choose meaningful colors for text data when no inherent color association is applicable. To answer this question, we present a semantic color mapping pipeline as a general guideline to facilitate the choice of colors in text visualizations. The pipeline summarizes design considerations, lessons learned, and best practices. In the following task, we briefly discuss the stages of the pipeline and present exemplary use cases. We start with text data and the task at hand. The text might be labeled or categorized according to some task-dependent criteria. We then decide on an appropriate aggregation level, for example, aggregating the text data by token, sentence, or other document levels, for example, or other occurrence levels, for example, documents. Following this step, we apply a vector representation method, like a language model, to create contextualized word embeddings or traditional document vectors. As an important step is the choice of a unit of analysis, which can be seen as a secondary aggregation step. The choice is directly related to the task. And for example, we may combine the individual vector representations of sentences or tokens based on a classified topic, or to create a single high-dimensional topic vector. The high-dimensional vectors are then projected to low-dimensional coordinates by similarity-preserving projection methods. The choice of projection method may rely on desirata, like a focus of preserving global versus local structure, or the presence of nonlinear input data. The resulting low-dimensional coordinates can then finally be translated into individual colors for each unit of analysis. We discuss multiple possible choices for color spaces that consider things like color perception and space coverage in the paper. And it's also possible to use a 3D color space with the correct projection. And then finally, the color-rated Jenner scale is not arbitrary anymore, but communicates similarity under the given unit of analysis and can increase comprehensibility of visualizations. And furthermore, with the right choice of methods, we're still able to preserve distinguishability. Let me give you 2 examples. So as a first application scenario, here is a concept space. In this first application, a hierarchical concept space is constructed based on an iterative human-in-the-loop, a topic modeling process. And here we apply semantic column mapping to the middle layer of the topic hierarchy or of the concept hierarchy. And the color mapping here serves as a second encoding of similarity besides the spatial proximity in the visualization. As a second example, there's a visual continuous topic modeling framework. Here the pipeline generates colors for identified topics with color representing semantic similarity between topics, and therefore, again, communicating additional information compared to a standard categorical color scale or continuous color scale. For the given pipeline, there are several additional design considerations that developers should take into account and that we discuss in the paper. For example, which kinds of tasks can be supported by this pipeline. The second important thing is the unit of analysis distribution, specifically the projection position of the chosen units of analysis. If analysis should be sufficiently spread out in the color space. And thirdly, the perception of color similarity can, of course, be subjective or even culture dependent. And based on the context, you might want to consider these additional factors for your application. And finally, we also identify 3 additional best practices which we recommend based on the surveyed work. For example, one should make sure that the shape of the projection and the color space match. For example, that the projection maze fills out the rectangular color map. For use cases where we have like incremental or streaming analysis, additional elements that can lead to clutter should be considered. And for example, to overcome this issue, we recommend the ability to manually recalculate the projection and assignment of colors via the user. And as a third recommendation, especially in scenarios where the unit of analysis are very close and become imperceptible, it's a good choice to give the user the ability to choose between different color scales on demand. So our message to you is make your color mapping meaningful. And to learn more, check out the full paper with a more in-depth discussion of the pipeline, highlighting individual design choices, a detailed description of the application cases, as well as the aforementioned section on design considerations and best practices. Okay, thank you very much.
So please put the questions on Slido. It's going to be a panel discussion later on after the presenters, 4 presenters have presented their work. The next presenter is Jonathan Roberts from the University of Bangor. There's actually about 14 authors on this paper. So yes, Jonathan. Yeah, the mic seems to be at my height.
Okay, so thanks very much. I'm Jonathan Roberts, and I'm going to be speaking on behalf of my many colleagues and co-authors of this paper. So I'm going to be talking about how can we help you in your education, in your teaching of students in visualization. And we, as educators, want to reflect on our own experiences, and we want to help other people to have best practices in visualization. And especially, how can we create visualization learning activities? So that's the thing that we're trying to help you to do. In my own teaching, I do some lectures, and then every lecture is supported by an activity. We get them to do something. And I think what we want to do here is to inspire you, to encourage you, and perhaps controversially, to guide you, to give you ideas, to give you best practice or perhaps things that worked for our cases that maybe you could take and adapt and put into your own situation. So what are these? Well, these are practical activities that we get students to do And each of them have a point. They are a learning activity, that they're doing something. Maybe this is cards, maybe this is physical activity, even physical, getting the students to move around, which is a great activity. Using whatever resources, however cheap or expensive we have, that we can get hold of to help us teach visualization and to be enthusiastic in our education. So these ideas came out of a Digital seminar that happened a few months back, where we discussed this whole idea of creativity in how can we be creative in our learning and how can we be creative in our education. And so this is a group effort, hence the 14 academics within this, and teachers and researchers. And I think as a team, we started to think, well, actually, there's a lot of things that we do here. We sketch, we do activities on paper, we do activities using tools, Tableau, D3, we get exercises. Some of them are really short, duration of a few minutes, others are really long. But can we think of ideas that we are using that may be useful to other people? How can we encourage people to be creative in their playfulness, but actually be learning something at the end of the day? So I like to think that this paper is basically a set of nuggets. So I won't have enough time to go through each of those nuggets. And in the paper, there's a bit more detail on each one of them. But we've got 9 nuggets. And I joke that this paper came out of a social event after hours, talking and discussing and saying we're all different, but we're all trying to get people to understand the nuances and the different ideas within visualization. And so these 9 ideas take different aspects of our teaching and focus on trying to focus on those things. So like making it fun is a really good inspirational activity that we can do. So I'm going to focus on three that we're going to think about. One is freedom. So in my own teaching, I allow my students to choose their own data set. They have to name it. There's a certain criteria that they have to fulfill. It has to be big enough that it won't work in Excel, but small enough that they can actually deal with it in the time limit in a few months of work that they have to do. So, but that gives them power. It empowers the student, empowers them to be mindful over what they're doing. But obviously that has ramifications on the academic, that adds a little bit of workload to us. We have to understand lots of different data sets. But there's benefits to that choice. Another thing is constraints. So not actually choice, but constraints. Actually telling and doing an activity where you can say, just in this activity, use a black pen, nothing else. No rubbers, black pen and paper. Or you might say, you have to use Lego in this activity, or some other type of building material. And building materials are really good as activities to get people to do different things. So cutting up bits of paper. I had one activity, got a newspaper and got them to cut up the newspaper and do a physical visualization of all the parts of that newspaper. So these are really physical activities that we can do using the resources around us. Okay, let's sort of draw things to a bit of a conclusion here. What are the choices? Well, I think not every one of us can do all of these different ideas every time. We have to make our choices. We have to make something which is for our own situation. We have to take these on board and say, oh, these are different ideas. Let's focus on some of those. I think choosing what your course is about is very important, whether it's a programming course, whether it's a course on Tableau, a course on art, or it's a course on design, focusing on what that is. But above all, consider who your audience is. It's not about us as educators, it's actually them learning, trying to understand the material. Okay, so hopefully I've encouraged you today to think differently, to think about your own teaching, your activities, and hopefully inspiration will come from that. Thanks very much.
So for our third paper, we have Edward He and Daniel Tolasa from Tufts University. only one mic, so you need to set up.
All right, hi everyone. Welcome to Analysis Without Data, teaching students to tackle the VAST challenge, presented by Eddie
and Daniel.
Okay, so what is the VAST challenge? For those of you who don't know, it's like an annual visual analytics competition, and it emulates real-world visual analytics tasks and problems. And this makes it a really good tool in Viz education because it allows students to learn based on realistic case studies while encouraging good Viz design and development practices. So what are some of the problems we want to address? So when students first tackle the VAST challenge, they face many difficulties, and the first of which is a cold start. And this is when students have trouble identifying a good starting point. And oftentimes when students have trouble identifying a good starting point, they also have difficulty coming to the correct solution. And the next is that students will often tackle a VAST challenge with exploratory data analysis. And this brings up the problem of serendipitous findings. So in Whiting's research, he finds that in some cases, students seem to serendipitously stumble upon the key component of the answer, and thus students either got most of the answer or none at all. So one way to combat these problems is with a hypothesis-driven approach, and how even when instructed to use a hypothesis-driven approach, student hypotheses were often very poorly written. So in this student's example hypothesis, certain visitors are irregularly active in certain regions of the park. The highlighted words show where there's like a lack of specificity, making this hypothesis really difficult to evaluate. So analysis without data, teaching students to tackle the VAST challenge. Our question is really, how can we tackle the VAST challenge without really using exploratory data analysis? And our proposed approach is through a hypothesis-driven approach where students are required to pre-register their hypotheses before conducting any sort of full data analysis. And it's very difficult for people to come up with hypotheses without looking at any of the data at all. So students are allowed to incrementally look at the data, and we outline that in our guideline. And the pitfalls of EDA, such as harking and serendipitous findings, can be minimized this way. So here is a visual of our guideline. And the main idea is that we want to discourage students from immediately trying to dig into the data. Instead, we want to encourage students to spend time reasoning through the problem. And so our guideline has 4 big steps, starting from problem understanding to problem data mapping to improving hypotheses and analysis questions, and finally, an evaluation.
So now we're going to move on to how we created the guideline. So when creating the guideline, our aim was to provide a step-by-step processes to help students come up to solve the VAST challenges and to be able to avoid the problem that we discussed earlier with the cold start. And we had a focus to encourage students to be able to critically analyze before doing any sort of EDA. So when we worked on it, we had an iterative approach where we came up together to discuss what we worked on, and later on we were able to refine it as much as possible. And for us to come up with our own guideline, we were able to reference other guidelines in the visual analytics community to help us kind of set expectations. So first, we worked on the 2017 VAST challenge with the goal of forming the guideline. And when we worked on the 2017, we had minimal exposure to the data. And once we worked on the 2017, we wanted to evaluate it and test it and see how it was. So we tested on the 2016 VAST challenge, and it helped us to reach the ground truth. So one of the benefits of the guideline is that it provided a streamlined process that was easy to follow, and it also provided concrete direction for each step. So for example, instead of just saying peek at the data, we were able to divide it into 3 different parts. So we said, look at the data schema, the summary stats, and the data sample. So one of the limitations that we had was that the guideline is only tested only on 2 students. And in order to combat this, we plan on performing experiments with more students in a visual analytics classroom. And this is currently work in progress. We plan on doing this spring 2023 at Tufts University. And the other one is we do plan on providing more details on how to perform data analysis. Our primary focus was on preventing negative aspects of EDA. And we do invite you to check out our paper. Thank you.
So please put the question in Slido with the presenter's name in front. So we have our final paper by Paul Parsons from Purdue University.
Okay, good afternoon, everyone. I'm going to talk to you about the role of guidelines in visualization design practice. I want to start by asking you to consider something for a couple seconds. What do you think how do you think guidelines relate to both of these concepts here, research and practice? There are probably several answers to this question. I think one of the more common ones looks something like this. Research generates guidelines, and guidelines get applied in practice. From this perspective, the role of researchers is to conduct studies, to generate knowledge, which then get captured in guidelines. And the role of practitioners is to know about these and apply them in their work. The underlying rationale for this perspective is that designers should be guided in action. How many people think that this is a reasonable statement? One, and the rest aren't sure if it's a good idea to say yes or no? Okay. I would have said yes at some point in time. I don't believe that it is really anymore after studying design practice for the past several years. And I'll tell you really briefly a few reasons why. So this statement is based on an underlying epistemology which the design theorist Donald Schoen refers to as technical rationality. Technical rationality is fundamentally positivist in nature, and as such, it rests on several assumptions about the nature of knowledge and professional practice. In one paper, Stolterman has identified 4 of these assumptions that are relevant for design. The first one is the supposed rationality of practice, with the assumption being that the application of knowledge, of objective knowledge, makes design rational. The second is the transferability of this rationality, and the assumption being that guidelines embody rationality. And as such, this rationality can be generalized and then transferred across contexts, across situations and practitioners. The third is in relation to the role of the designer. If guidelines are rational, if they're objective, and if they're transferable, then the design outcome doesn't really need to depend too much on the individual doing the design work. And the fourth is about controlling the design process, with the assumption being that if all of these other things are true, then guidelines can help control the process, and in doing so, make the outcome more predictable. These might all sound reasonable, but I think the key question here is what's the empirical evidence that these are true in practice? And our position is that when we look at the evidence, we look at the literature that exists, and based on our own work, these assumptions are not good. They're not true, and in reality, they're more like fallacies about design and the role of knowledge in professional practice. Based on this, we suggest a few areas of focus for doing research on guidelines in the future. One is about practice-focused inquiry. We need to recognize design practice as a unique activity with its own epistemology and its own ways of working. And we need to study practice as it's done in the world rather than practice as we imagine it to be done. The second is about tacit and explicit design knowledge. We need to recognize that facets of design knowledge cannot be codified and they're not objective. And we need to study the relationship between guidelines and tacit knowledge that designers possess. The third is about educating future designers. We need to recognize the role of situated judgments in design practice and study how to make students prepared for action rather than guided in action, which is based on this notion of technical rationality that I mentioned. Thank you.
So as we are running out of time, we're doing a bit of rescheduling. We're going to do the Q&A for including the virtual and the in-person after the coffee break. So what we would ask everyone to do is during the coffee break, please put question on Slidos with the author's name and the questions, and all the authors would be back here. We'll have the Q&A, and then after the Q&A, we have the breakout session. So see everyone later. So think of questions to ask. So thank you. So the link on the Slido is on the virtual VisGuides website.